Hey, what's up guys, it's Mike Tech back again with another video, and today we're going to be taking a look at FreeCAD and a cool new feature that I just found out about called Path in FreeCAD. Now what this cool new feature is about is a G-code generator. So if you ever use or if you ever had a CNC machine before, you will know that CNC machines use G-code in order to make them cut out parts and stuff like that, and the only way to actually get that G code is you can either write it by hand or you can generate it with a G code generator. And it turns out FreeCAD has one inside of it already, which is cool because it's free and you don't have to pay for it, unlike a lot of the alternatives, which I'm going to go through real quick. You know, you got Fusion 360, which is CAD and Cam all in one software. You also have SolidWorks, which also has a Cam software option, and you also have Mastercam, and you have Meshcam, which is actually the cheapest out of all of them. This one here is around $500 for the Pro and around $250 for the Standard, which is a good option. I've actually used this before and it's actually pretty good. I like this software, but I do not want to pay $250 or $500. I would like to have a free option for now. Later on I might upgrade and pay, but for right now it's cool to know that I have FreeCAM, which actually has a path generator inside of it. So not only can you draw stuff, but you can also create the G code for the stuff that you create in FreeCAD. So let's get started real quick. Now I already imported my model. I'm just getting started with this whole FreeCAM software, so I don't really know how to really use it yet. I don't know how to draw stuff in it, but right now I'm just using it just to generate the G code. So I imported my model as a STL file from a different piece of software that I use, which is way easier to use. Later on I'm going to learn more about this piece of software, but for right now let's just import the model, which I already did. It's STL. After you did that, if you don't know how to do that, I have a video. I will link it down below, and you can click on the link and it will take you to a video where I show you how to import STL models. But I'm gonna go ahead and convert this model to a file, to a mesh that I can actually use to generate the G code with. So I'm gonna do that real quick. I'm gonna go over to where it says part again, create a mesh, set the resolution down to the lowest point. Is going to create the mesh, convert this mesh to a solid, and then refine the shape to get rid of all the lines. And now I'm going to toggle the visibility so that way you can see the finished version. Real quick, toggle visibility, and now you can only see the refined version, which is what I want. So now we're gonna head over to the good stuff. Now we're gonna head over to Path, and once you get into Path, this toolbar at the top will change, and you will see this little green icon, which is the only clickable icon up here besides these ones. They're always highlighted, they're always clickable. You will see this little icon here. It'll say create a path job object. Click that. You will only see the options that you have converted. So you will see the first one, the second one, and the last one. I want the last one because this one here is the refined solid. So this is the solid that we refined. I'm gonna go ahead and press that. It's going to show up with another little box. To keep this video nice and short, I don't want to make it too long. I'm not going to I'm not going to put in the actual size of the stock. I'm just going to have the stock be the size of the actual part. Now if you don't know what stock is the material that you are going to make, or stock is the material that you are going to be using to create the part out of. So if you're using a piece of aluminum that is 4 inches by 4 inches and your part is only 3 inches by 3 inches, that 4-inch part that you're using is called the stock, and then you will create your part from that stock, from that piece of material that you're putting inside the machine, and it will get cut down to the size of the part, and you know, all the other stuff. So I'm not going to put in the actual size of the stock. I'm just going to keep it simple, and the stock is going to be the size of the part, just to keep it simple. You will see here that you have these little arrows here. You have this blue arrow, the red one, and the green one with a little circle at the bottom where my mouse is. This arrow here, these set of arrows, is called the origin point. Now, one thing I found out the hard way by doing a lot of trial and error is that the origin point is where the machine is going to start. So you can zero your machine at the part, at the stock part, at the top of the stock. You can zero your machine there, but that doesn't mean that it's actually going to start there. It's going to start where this origin point is. So if you use this, you have to make sure to set your part at the origin point. And the way to do that is you want to make sure your mouse is set to CAD here. So you want to click CAD, and now you want to highlight anywhere on this part. It doesn't matter where you highlight, you just got to highlight it anywhere. Just click on it and it will change the color. And now you have these arrows over here that you can click on, and you want to go ahead and make sure you can see it from the top, and then move it down and over, so that way it lines up with the origin point, which is right there. That's good enough for me. I'm gonna go ahead and move this around just to make sure it's straight, to make sure it's good. And I like that where it's at. I'm gonna go ahead, go back up to the top, make sure this box is moved over to where I want it. So now the box is around the actual part here. It's not over here where it used to be before. Press OK. Now we're gonna go back, and I want to put in the tools now. So now we're gonna go, well, you know what, let's go to output first. So output, you can only see where it says processor. This is where you choose your CAM processor or your post processor that's going to generate the G code that your machine is going to run. You only see two here. If you want more options, let me go up here to where it says edit, go down to where it says profile, go down here where it says path, job profile, and then click on where it says post processor. And then post processor, there's a little box here where you have a list of post processors here. Now, if you do not see your post processor inside this box, you might have to create your own and put it inside FreeCAD, so that way FreeCAD can actually use it as a post processor. But for me, I am using a piece of software called CNC, which is based off of Mach 3. So I'm gonna guess and say that this post processor will work for Mach 3. The post processor that I'm using is called Linux CNC, so that's what I'm using for CNC. I'm gonna guess and say it also works for Mach 3, maybe Mach 4, but I'm not sure yet because I haven't used Mach 3 or Mach 4. Right now I'm only using CNC because I like the way it looks. I like the fact that it already has a tool changer built into CNC, which is nice. And I also like the fact that it's a lot cheaper than Mach 3 or Mach 4. So that's why I'm using CNC right now. But technically Mach 3 and Mach 4 is a little bit better than CNC, but that's a whole nother story for a whole nother day. But for right now, like I said, I'm going to be using Linux as the post processor because it works with CNC, and I'm too lazy to make my own post processor, so I'm just going to use this one for right now. So I'm just going to type in a random name, which is going to be the name of the file that is going to output. So this is just for a video, so I don't really care about the names. I'm just going to put in whatever. We're going to go over to tools. Now we're going to start setting up our tool list. Now this software does support a tool changer. So if you do have a tool changer on your machine, it will work with this software here, which is nice. A lot of the free options that you have out there right now, which is like PyCam, and you have a couple other free options as well, they don't always support tool changers. Not all of them do. I know PyCam does, but I think the other ones don't. This one does, and it's free, so that's another plus for this right here. So I'm gonna go ahead and highlight the first tool, which is a high-speed steel 3mm 2 flute end mill. So I'm just gonna go ahead and click the little box. It's gonna highlight down here where it says create tool calculator. Press OK. Well, actually no, my bad. Don't press OK. Press create tool calculator. Press that, and then it's gonna put it over here in the box. Press OK to get rid of the window, and then after you do that, I never use the default tool, so I'm gonna get rid of the default tool just by pressing remove. And I'm only gonna keep the tool that I actually use, and I'm gonna put in my feeds and my speeds. So my feeds is here and here, which is, let me go here, let me click, let me see, does it show it here? I think it does. No, actually it doesn't show what those that is. Okay, so what I do know is that this is your feeds here, and then this is your spindle speed, which is here. So for me, I'm going to use 20 because I am using a very small CNC router. It's one of those little Chinese routers. It's a 6040 router that you can get pretty much off of eBay. Nothing fancy. So I'm not gonna have my feeds too high, and then my spindle speed is going to be set to 3000. Press OK. So that's how you type it in. So you just highlight the box, just double click it, and then it's just gonna show up, and then you just type in your number. So let's change this view back to the top. Let's rotate a little bit like that. Now we are done with this box for right now. Now this is just how I set it up for now. Like I said, I'm still learning more about this software on how to use it properly. So as I learn more, I will make more videos about how to use it. And I just want to let you guys know that there is a free option out here. So what we're going to do now is we're going to go ahead and cut these grooves out. So what this part is actually a heat sink for a LED lights that I'm putting together. Is for a camera light. So I'm making my own camera light. I don't want to buy one, so I'm just going to make it myself. And this is the heat sink for those LED lights that are going to be attached to this. So what we want to do first, we want to cut out these grooves for the heat sink to make it a heat sink, pretty much. So we're going to go to up here at the top where you have your list of operations that you can do. So you can do a create a contour path. You can do a facing path, right? Or profile based on face or faces. You can profile based on edges. You can create a path pocket object from a face or faces, which is what we're going to be doing. You can also drill here, or you can do a facing operation and many other operations as well. But for right now, we're just going to do a pocket operation because these things here are called pockets and we need to cut them out. So the first thing you want to do is go to where it says basic geometry, and we want to highlight all of our geometry in here, and we want to put it in this list over here. So I'm going to go ahead and do the first one, and then I'm going to speed it up, and so you guys don't have to sit there and watch me do all of them. So the first one is pretty easy. You just click on it. So you just click on it until it turns green, and then you come down here to where it says add, and you add it in. And now that you see how to do that, it's pretty much the same for all of these. So I'm just going to fast forward. I'm going to do all of them, and then after I get done, I'm going to come back. So let's do it. Okay guys, I'm back and I'm done highlighting all of my geometries and putting them inside this box here that you can see. I highlighted pretty much all of them. Now we're going to go ahead and press apply to make sure all the changes have been put in, and it's going to calculate the path for all of them. And now we're going to go ahead and refine that path. So the way we're going to refine the path is going to go over here to where it says depth, and we're going to put the step down depth. Now by default, the step down is actually the size of the tool. So if the tool is 4mm, the step down will be 4mm. Obviously I don't want it to step down 4mm because that's a little bit too much for my tool and a little bit too much for my machine. Well, my tool is actually 3mm, but either way, it's a little bit too much. So I'm going to go ahead and change that, and I'm going to go ahead and put in my step down, which is going to be 0.20 or 20 thousandths, and go ahead and press apply, and you right away see those changes here. So there you go. Now you see that the lines have gotten a little bit more thicker, and the reason why is because there's more cutting that's happening here, because there's more steps downs that it has to do, more layers, which makes the line look thicker. But yeah, where it says finish depth, we're gonna leave that at 0. Final depth, I'm gonna come back to this because this actually it gets kind of complicated here, but there's a reason why, and I'm gonna come back to that. And then start depth, I'm gonna change this to 0.20. So I'm gonna put 0.20, press OK, and that's it. Okay, so now we're gonna go to where it says final depth, and we're gonna change that one. But before I change it, I want to explain something to you real quick. So you see this height here? Let me change this. Let me get it right. Okay, so right here, this right here is the origin point. Now remember, a couple minutes ago we set the origin point so that way the origin point was in the corner right here. Now you can see here that these red lines is where the tool is going to be traveling. Now you can see it coming up and then going all the way over here, and then it comes down over here, right here, and then it goes and then it starts cutting. And then the green lines are where it's actually going to cut. The red lines is where it's going to travel. Now, one of the problems that I ended up having with this piece of software when I first started using it, something that I didn't quite understand, was that I set the origin point over here, which is actually the face, is actually the top of the part. The top of the part was my origin point, was my 0 point. Now it will move up from that and then move over, and then it will start cutting down. But as it's cutting down, it wouldn't actually be cutting the part, it would be cutting air. So it wouldn't actually, the tool wouldn't actually be doing any work. It would just be sitting there just cutting out the air, and that's it. It wouldn't be cutting anything, which isn't good for me. So what I had to do in order to make it actually cut the part was to change this number here and put, where it says final depth, I would keep the same number but just put a negative in front of it. So I would put 2.20, which is the same number that was already here, but I just put a negative in front of it. And the reason why is because if you set your 0 point as the top of the part, so basically if you have your 4mm by 4mm by 3mm piece of aluminum that you're cutting out, and you zero the tool at the top of that piece of aluminum, it's gonna think that that is the bottom of the part, and then it's going to move up whatever height this is. So the height of this part is around 5mm. So if you set this top part, which, let me change this so that way I can highlight it. If you set the top of this part as your 0 point, it's gonna move up from that, whatever the height is of this. So the height of this is 5mm. This is the top of the part, which is 0. It's gonna move up from that 5mm, which basically means it's going to be above your part cutting down, and it's not going to be cutting anything. It's just going to be cutting the air, and that's it. So you don't want it to move up and then start cutting. You want it to just move down and cut the part out. So the only way to do that is to have it set as a negative number here. I know that might sound really confusing to you, but I'm going to put a video here that's going to actually show what I'm talking about, and you will actually see it moving up and then just start cutting the air, which is not doing me any good at all. So the only way to change that is to put the negative number, which I did right here. I put the negative 2.2mm to put that negative number, and then it doesn't move up, it just moves across to the start point. And then as it's moving across to the start point, then it starts to actually go down and cut into the material, which leaves me with my part that I'm trying to create here. So I'm gonna put that video in. Hopefully that video helps explain what it is I'm talking about, but if it doesn't, you'll find out as you're using this piece of software. That you just did is actually going to take effect. So make sure to press apply. Don't just press OK, press apply too. So now you will see that the green stuff that was at the top has now moved to the bottom because the top of this part is 0 and I want it to move down from 0. So I don't want it to start where the red line is. I want it to start where the face or the top of the part is and move down from there. So that's why these lines are at the bottom. Hopefully you understand what it is I'm talking about, but let's move on from there. I don't want to talk too much about that because, you know, I don't want to make the video too boring, but let's move over to where it says height. I always leave this the same. I never change it, so I'm just gonna skip this part and I'm just gonna move over to this part here. And now we're gonna get into where it says more options here, where you can just set up more of your cut parameters and stuff. So right here where it says tool controller, this here, you're gonna have a drop down box here where the list is going to be of all the tools that you have selected. I only selected one tool, so this is the only tool that's going to appear. And now after we select this tool, which is the only tool that I select, now you have cut mode. I always leave this as the regular cut mode. I never really change this. I just leave this the same. This right here is where you have all your different cutting types. So you have your spiral, you have your line, you have your grid, you have offset, which is you have zigzag and offset, or you can just choose zigzag. I'm just gonna go with zigzag for now. It's pretty self-explanatory. So spiral is when it's gonna start in the middle and it's gonna go out from there, and then zigzag is where it's going to just zigzag back and forth. You have lines where it's going to go straight and then come down a little bit and then go back again and then come down, go back again. And then you have what else is on here? You have grid, where it's going to be a grid, so it's going to go this way, then it might go this way, then it might go this way and this way. It's going to do a whole bunch of different stuff. So yeah, this is all your different cutting types here. You have angle. I always leave angle the same. Step over, this is how much is going to step over between every cut. So if this space here is about 3 millimeters and my tool, well, this is actually 3.4 millimeters actually, and my tool is about 3.1, so it's gonna step over less than 100%. Or let's say, for example, this is actually let's say that this is 5 millimeters and my tool is 2 millimeters. Stepping over 100% would be stepping over 2 millimeters. I don't want it to step over 2 millimeters because I'm using a pretty small spindle and a pretty small tool. My tool is only 3 millimeters, so I'm going to put this to 25% step over. So it's only going to step over 25% of the diameter of the tool. So if the tool is 2 millimeters, it's only going to step over 25% of that 2 millimeters. This, I always leave that the same. I never changed it. Use start point. So the start point is going to be the origin point over here, and it's also going to be where the 0 point is of the machine. So that's where I want it to start. So I'm just going to highlight that. I'm going to press apply for all those settings, and now all those settings have been applied. So now we're looking pretty good now. So that's pretty much it just for this simple part. I'm going to do another video explaining how to cut it out and how to do the holes and stuff like that. But for right now, this is how to do pockets in FreeCAD Path, which is pretty cool piece of software. It's pretty easy, pretty self-explanatory. It's not that hard to learn. There are other videos on here if you want to, on YouTube, if you want to look it up. If I didn't do a good job explaining this, hopefully I did. Hopefully you liked this video. Hopefully you enjoyed it. Hopefully this video makes you want to subscribe, follow me on all social platforms, Facebook, Twitter, Instagram, Subscribe to my YouTube channel. Make sure to comment at the bottom if you need more help, if you want to ask me a question about something. Maybe you want me to go in more detail about something. Feel free to just comment that at the bottom. What else? I also have a website that you can go to. I have stuff on that website that you can buy that helps support me. It helps make me want to make more videos. Every time you purchase something from that, all that money goes into me buying stuff so I can make more videos with. So that is what that's for. And I also have an Amazon store, and I also have an eBay store. So make sure, like I said before, subscribe, like, comment, follow me on all social media platforms. All the links are going to be down below. And if you want to support me, go over to the eBay, Amazon, and my website to purchase any type of merch you want. I have flash drives, I have USB cables, I have flashlights, I have everything on there. So yeah, check it out. So that's going to be it for this video. I'm probably going to go ahead and make more videos like this, explaining more about this free piece of software, which is actually pretty cool. Before I end it real quick, let me do this. Let me go ahead and show you guys. This is the G-code simulator. I know the part is kind of like off a little bit, but ignore that. But this is basically the G-code simulator. So this is going to simulate the cut that I'm going to be doing. So you can see the tool there is moving and is cutting out the part. I know it looks kind of weird, but it's gonna be fine once you see it inside the machine. It's gonna work, trust me. I've used this piece of software plenty of times before. So I'm just gonna go ahead and let me get rid of this because I don't need this on here. And I also want to show you guys the actual G code. So you want to come up here next to where you see create path job project, you will see post processor. So you want to click that, and then the name is going to appear down here. I want to put it on my desktop. That's where I want to save it, and then just press save, and then it's going to go and generate the G code. And any minute now you will see the G codes on the screen. Check that out. So that's all the G code for this project that I am working on. So there you go. So that's all over there. And then you can save this wherever you want. You can save it to a flash drive. You can save it to an SD card. You can save it to your desktop. Wherever you want to save it, you can save it. And like I said, this software is free. It's a lot cheaper than all the alternatives because it's free. You don't have to pay for it. So yeah, like I said before, like, comment, subscribe, follow me on all social media platforms, and check me out on Amazon, eBay, and my website. So yeah, peace out. Enjoy.